So let's be on page, let's just start right on the front. Right on the front. We can do this of our packet, page 1. We can do most of both sides of this, not quite all, but after today we'll be able to do it all. So here we go. A plus 2B. Now, remember that sometimes you can't add. The rules for addition are very specific. What are the rules, or what is the rule for matrix addition? How do we add? No, addition. 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 They have to be the same size, right? If we're going to add them, they have to be the same size, because how do we add matrices? What's our procedure? Yoo-hoo! How do we add matrices? You just go with the same position, right? You add corresponding entries. So I'm going to add this number to this number. Now, matrix B is getting multiplied by 2, which is called a scalar. And so I'm going to be adding what? What's going to go in here? 2, 2. Okay. So now I'm going to add these two together, and I just add corresponding entries. So here we go. The first number right here is going to be a 3. Number 1. 4. And there we go. So there's the sum. Those were able to be added, and we did so just by adding corresponding entries. Now, number 2 is a subtraction. So we are going to take matrix C and subtract matrix B. All right, what do you think about this? You can't do it. So number 2 has no answer. You can't do it because why?
They don't match.
They don't match. They're not the same size. And when we add and subtract, they have to be the same size, and they're not. All right, what does number 3 mean? A sub 2, 1. What does that mean?
The second row.
That means, first of all, look at matrix A, right? And in matrix A, which is this one right here, I want to go to the second row in the first column. So I'm looking at that number right there. So that is the entry, the number in matrix A that is in the second row, first column. So that would be right here. What are the dimensions of matrix B? What? 2 by 3. That's a 2 by 3 matrix. B is a 2 by 3 because it has 2 rows and 3 columns, right? So B is a 2 by 3. All right, now we're going to multiply C times A. So C times A. Now the first thing we need to do is figure out if that's even possible. Because remember, sometimes, just like you can't subtract sometimes, you can't multiply sometimes. So how do we check to see if it's possible? This is kind of what some of you were talking about before. So this is a 2 by 2, 2 rows, 2 columns. This is a 2 by 3. The middle 2 numbers have to match, and they do. So that means we can multiply, and our answer will be a 2 by 3. These 2 numbers give me my answer. So I have 2 rows and 3 columns. So I figured out I can multiply because these match. And now I'm going to actually get the numbers inside this matrix. So how do I get this guy right here? That first number right there, first row, first column, I do a dot product. And remember, to do a dot product, it means x times x, y times y, add them together. So first times first, second times second, add them together, that would be a -2. 1 plus -3. Alright, then you can go anywhere you want, but if we move over here, now we're in the first row and the second column. So that's -1 minus 4. -1, -4, so that's going to be a -5 there. Remember, you're doing first times first, second times second, and adding them up. Okay, first times first, second times second, adding them up. All right, so now I've got first row, third column. So that's 2 and 0, so that's a 2 right there. Now you're going to do exactly the same thing on the bottom, except these are now in the second row, so you're going to use your second row and multiply your second row times each of these columns. All right, so go ahead and do that and let's see what you come up with. See what you come up with for those last 3 positions. So, what do you got here on the bottom? 23. Put your hand up, honey. You need to go to nose? Yep. You need to go to the nose? Okay, keep your hand up. What'd you put here? 23? And then?
26. 4.
What do you think? I didn't do it. What do you think? Everybody agreement? Those numbers are right? Okay, down at the bottom then we have, this is not a matrix operation, but this is in section 7.1. It's one of these system problems. So let's go ahead and do this. Okay, so your job is to solve this system. If you were going to draw a picture of this, which we're not, but if we were, what shape would that be? That's a line. What shape would that be? Ooh, it's a parabola. Oh, don't admit it. That's embarrassing. This isn't a parabola. This is a circle, right? How do I know it's not a parabola? It's got 2 squared terms. It's got 2 squared terms. That's not a parabola. Unless there's a rotation in there, which there is. All right. So we've got a circle and a line, and so we could have 2 solutions, 1 solution, or none. All right. How are we going to do this? What do you want to do?
The top row, you can get y by itself.
Top row, you can get y by itself, she says. So doing a little rearranging, it looks like y equals 2x minus 3. All right. And Taylor, what was the purpose of that?
So you can plug it into the second person.
You do a little substitution. We're going to take that guy and plug him in right here. So we have x squared plus 2x minus 3 squared equals 5. Now what?
So, foil.
Foil, foil, foil. That's right. This is going to be a foil. So either do it over to the side or do it in your head. It's up to you. Whatever works. But you got to foil that out. You don't just square each piece. Foil it out. So now I've got 5x squared minus 12x's plus 4. Is that right? So at this point, if it factors, you can go ahead and factor it. Now, if it doesn't factor, or if you don't want to mess with it, a lot of you don't like to mess with it when it's got a number out here. If you don't want to mess with it, I think that's it though. You can always use your quadratic formula, right? That's always an option for you if you don't want to factor it. But this one does factor. Looks like I'm going to have 2 points of intersection, and remember your answer is ordered pairs, points, because you want to know where this line and this circle cross each other. Well, 2/5 or 2 are the x coordinates. So I got 2 points, and the x's are 2/5 and 2. I'll do 2 first. If I plug 2 in, looks like my y is 1. And if I plug in 2/5, I get 4/5 minus 15/5, negative 11/5. And there are my 2 points of intersection. All right, let's turn it over. Now we got a determinant. Did we get to these last time? No, did we get to any determinants last time? Okay. All right, so we need to hold off on that. Let's go down and do number 4. We can do number 4, and then we'll come back up and do these other ones. Because we gotta get that down. So we're going to skip, we're on the back side of page 1, and we're starting at the bottom, because those we know how to do. We gotta learn the rest of this page today. That's our goal. All right, so we want to multiply A times B. I'm on number 4, down at the bottom, 4A. I'm going to multiply these. Okay? So the first thing I do when I have to do a multiplication problem is I figure out if I can even do it. All right, so what have I got here? How big is this? 2 by 2. The dimensions are 2 by 2. How about this one? 2 by 2. So now I'm going to multiply those together. Okay? And since I can, my answer will be another 2 by 2. So we have 4 numbers to fill in. So what would those be? Row 1, column 1, looks like a 1, and then column 2, looks like another 1. Double check me, please, don't let me make a careless mistake. 28, and negative 5, is that okay? A minus 2B. Is this going to be doable? Remember, for subtraction, they have to have the same dimensions, right? And they do. So we're going to do A minus, all right, so let's choose this thing, 4, negative 2, 6, and 0. I took 2 times that. Is that okay with everybody? Now I'm going to subtract. So my answer is, when I subtract, negative 5. You got to keep track of all these signs. Okay, did I do that right? Good deal. Yeah, multiply by the inverse, and that's one of the things we're going to do today is talk about the inverse. Yeah.
No, like when you multiply
All right, now, the next thing we're going to talk about is the determinant. Letter C says find the determinant of C. And that is not going to be possible to do, because in order to evaluate a determinant, a determinant. Don't get that confused with discriminant. The discriminant is b squared minus 4ac. This is something totally different. This is the determinant. In order to do a determinant, the matrix must be square. So look at matrix C down there at the bottom. Is it a square matrix? What we mean by square is it has the same number of rows as columns. Is matrix C square? No, it has 2 rows and 1 column. Since it is not square, you cannot evaluate its determinant. The determinant is just a number associated with the matrix. So if I were going to find the determinant of matrix A, this is not a question on the paper, but I'm using matrix A. The notation I would use is these vertical bars. Now you have seen those vertical bars before when we studied vectors. Who remembers what the vertical bars meant when we studied vectors? Magnitude. And magnitude is just a number, right? Like the magnitude of the vector is √7 or something. The determinant is just a number. To evaluate it, very simple. To evaluate it, you take -1 times 6 and subtract 5 times 1. So to get the determinant of a 2 by 2, and remember they have to be square. So 2 by 2, that's where we'll start, the smallest square. You take this number times this number, so it's got to be in this order. You've got to go this way first. And then minus this way. So that's -6 minus 5. The determinant of that matrix is -11. All right, what about the determinant of B? Again, this isn't a question on the quiz. We're just doing it for practice. What is the determinant of matrix B? So you're going to start here. You're going to do that multiplication first. So what do you get when you do that multiplication? 0. Minus, always minus. And then this multiplication, which gives you a -3. So if you said the determinant was 3, you are right. It's 3. Now at this moment in time, you're thinking this is really cool and I can use it for, you're going to see. We have a couple uses for it. But right now we have to figure out how to find them. So that's how you find the determinant of a 2 by 2. Let me throw one more up here. You do this one on your own. What's the value of that determinant? Patty?
It's 20.
It's 20. Everybody getting 20? You're good? All right, now go back up to the top of this quiz and you'll see the determinant notation. See those straight lines? That means you have a determinant. Those bars mean a determinant, and you're going to evaluate it. But this one is bigger. It's a 3 by 3. So how do we do a 3 by 3? Well, we actually do the same thing, basically. We take this diagonal minus this diagonal. But since there are more numbers, we have a little more arithmetic involved. So, take these first 2 columns. You remember this from last year? Take these first 2 columns and recopy them. Oh, yeah. So you're just going to take the first 2 columns and recopy them, including negatives. Make sure you copy them exactly. Now, we're going to start right here. This is where we always start. Think about it like this. If you were going to write this set of numbers down, isn't this the first number you write down? That's where you start. So you multiply that diagonal together. And what do we get when we multiply that diagonal? -6. Now I'm going to multiply this diagonal. I get -4. And then I'm going to multiply this diagonal. So I am multiplying all of these diagonals, and I get 0. Now total those up. What is the total of that? -10. So this diagonal totaled -10. Now guess what I'm going to do?
Okay, so do you add?
To add them up. Okay. Now I'm going to come over here and I'm going to do the same thing this way. So that one is 24. That one is 0. And that one is 0. So when I total those up, I get 24. So this was -10. This was 24. What do you think I'm going to do with those two numbers? Subtract them. Kids, what do you do over here? Don't you take this diagonal minus this one? That's what you're going to do. You're going to take -10 minus 24. So the answer is -34. The value of that determinant is -34. Alright, so let's have you try another one. Not on the quiz, but just for another practice. Alright, let's find the value of this determinant. Alright, so what do we do first? Rewrite the first two columns. So -1, 0, and -2, and 2, 1, 1. Rewrite the first two columns. And then we multiply. Let's see, what is that? -16. And multiply. So those total up, if I did everything right, it's easy to make mistakes here if you're not paying attention. -15. Now I'm going this way. That will be -6, -4, and 0. So that's -10. So what's the answer to the problem? -5. Because it's -15 minus -10. So that's going to be -5. Okay? Now, anything bigger than a 4x4 is handled in a different way. It's we have a procedure called expansion by minors, and it takes a lot of space and a lot of time. We used to actually teach it, but we don't anymore. What we do now is, if we have a 4x4, we put it in our calculator. So let's talk about how to do that. Remember, you have to be square to have a determinant. So we will never be talking about determinants of things that aren't square. Alright, so let's say here's our determinant. Alright, so we're gonna evaluate this determinant on our calculator. So looking at all the buttons on the front of your calculator, where do you think we might start? No, but that's a good, we are actually going to do a math function, but it's going to be in our matrix menu. So we need to go to matrix, which is right below the math key. See it? Matrix. Now, you got lots of options across the top. I want you to click over to edit. Whenever we want to put a matrix into our calculator, we have to do it through edit. So we went to matrix, we're over to edit. All right, press enter. Now, you may already have something in there. I don't know if you do or not. It doesn't matter. We're just going to type right over it. It's not an issue at all. It never is. first thing the calculator wants to know is how big is your matrix. This has how many rows, how many columns, so we type 4 by 4. Okay? Now again, if you already have numbers there, it doesn't matter. Just type in your new numbers. So just put them in. It's just going to replace anything that maybe was already in there. If you told it was 4 by 4, it's going to give you places to put all those numbers. All right? As soon as you get them in, and you've pressed enter, so the last number is in there, and you press enter, then I want you to go and second quit. Just exit out. So go back to your home screen. Get out of the matrix menu. Now I want you to go back into the matrix menu, and this time, we're not going to go into edit because we already got it in. We're going to math. So click over to math. And you see the very first thing says determinant? Press it. Now on your screen it says this, right? So it's asking you, okay, I'm ready. What do you want me to find the determinant of? So go back into matrix and press A. Should be highlighted. That's where you just put your data. Put A, press enter, and the value of that determinant is 4. That determinant right there has a value of 4. Okay, let's check our work for this one. We did this one by hand and we got -5. Let's put it in and see if we get -5 on the calculator. Now, when you put it in, you're only putting in the problem. Don't put in those extra 2 columns. So we'll go into matrix and across to edit. Now, how big is our determinant now? 3 by 3. So we'll put in 3 by 3, and then we'll just type in those numbers. As soon as you get them all in, exit out of the matrix menu, go back in, sure enough, did you get -5? So you need to be able to find a 2 by 2 determinant and a 3 by 3 determinant by hand. Anything else, we're just going to type in the calculator if we need it. Okay? Getting this sorted out. Olivia, I got a collection of iPads up here. Should I take yours too and put it away? All right, so let's talk about 2 applications of the determinant. All right, everybody knows how to find a determinant now, right? 2 by 2, 3 by 3. Now we're going to talk about what we use them for. All right, did you guys talk about Cramer's rule last year? Does that sound at all familiar to you? I'm still on this quiz, backside of page 1. I'm looking at problem number 2. This is an application of Cramer's rule. Now, if I told you to solve this system, what would pop into your head? If I just said, here's a system of 2 lines, solve them, what would you think about doing? Oh, you think about eliminating? Some of you might think about substituting. That's how you've done it for forever. Well, we're going to have a new option now, and we'll talk about a really big advantage to this new option. And that's called Cramer's rule. Now here's how Cramer's rule works. It's real simple. Step 1 for Cramer's rule is find the determinant of the coefficients. So when I say coefficients, you know what I mean, the numbers attached to x and y. Now, it's really important that you have the x's lined up and the y's lined up. So make sure your equations look like this. Okay, everybody see what I did here? Now, what's the value of that? You can evaluate that. What is that? That's 7. All right, how did she get 7? Everybody getting 7? It's 1 minus -6. That's 7. Now, that number, remember, when you're solving the system, you're looking for an x and a y, right? That's what you're trying to find? That number that you just got is going to be the denominator of both x and y. So in other words, x and y are fractions with 7 in the denominator. This number is always the denominator of your answers. Now, what about the numerators? Well, the numerators are other determinants. And how you find, let's focus on x. We're going to do x first. Very simply, pretend you have a pair of scissors. Cut these numbers out, the constants over here that you haven't used yet, you haven't used those yet. Cut those out and paste them on top of the x coefficients. So again, when you set up this determinant, you have a column of x's and you have a column of y's. If you are solving for x, cut these out and paste them here. So you'll have -7, 7 and -3, 1. That will be that determinant. I cut these out and paste them right here. Now, how do you think I'm going to set up my y determinant? Same thing, except I'm going to cut these out and paste them here. So I have 1, 2, and -7, 7. Okay, now I'm going to evaluate this. So what's this determinant up here? -7 minus -21. What is that? 14 over 7, so my x value is 2. What's this one? (21) over 7, so my y value is 3. Now, I know exactly what's going through your head right now. You're thinking, you gotta be kidding me. I'm gonna substitute or eliminate. I'm not gonna do this. Can you think of a possible advantage to Cramer's rule? Especially those of you that are fraction phobic and not very good at it. Stop and think about what happens when you do a substitution or elimination. Sometimes when you solve, you get an answer like x equals 13 15, let's say. That happens, right? So then what do you have to do with that 13 15ths? You have to plug it back in and figure out what y is and deal with the fraction and work with the fraction and common denominators and all that stuff, right? Shouldn't be an issue. It's third grade stuff. Shouldn't be an issue, but it is for some of you, right? If you use Cramer's rule, does it really matter? Let's say you've done this and it came out to be 146 over 7. Does that even bother you? No, you don't have to deal with it. You just write it down, because then you do this one and it turns out to be 213 over 7. Okay, great. If you do Cramer's rule, there is absolutely no need for much arithmetic. I mean, you don't have to plug back in and evaluate and deal with all the fractions.
How would you know whether or not there's going to be 2 answers though? If it's squared, like how would you do that?
Okay, we're not going to be doing Cramer's rule with anything except linear equations. Well, I shouldn't say that. Variables to the first power. Cause we can do it, like if we had a system that was x plus y plus z equals 3 and 2x minus y, you know, we can do that. The determinants just are bigger, they're 3 by 3s. But as soon as you put a squared in there, no. Now, sometimes though, when we do lines, Ross, so 2 lines, sometimes we have issues with these too. Remember, sometimes you get no answer. You'll know that with Cramer's rule, because when you do your very first determinant, it will work out to be 0. And how will you know then, oops, something weird's going on? Because what do you do with that number? It gets in your denominator. So if that's a 0, you've got a weird situation. And then you're gonna have to think about this problem and maybe do substitution or elimination, or are the lines parallel, kind of look at them, are they the same? So that will be your clue if something happens there. All right, let's do another example of Cramer's rule. And I'll make this one up so it won't be rigged. And so we'll get these nasty answers, but it won't matter. It won't matter. We don't even care. I'd say 3x plus 4y equals negative 11. And negative 2x plus 7y equals 13. Totally made up, probably gonna get an awful answer, doesn't matter. I'm gonna use Cramer's rule. Patty, do you remember what the first step to Cramer's rule is? The problem I just did? What did I do first? I make a determinant, a matrix, you have to determine it, and what goes in there?
The x column goes in the leftmost column, and the y values go in the...
You are exactly right. So I'm gonna evaluate that, right. So what would that guy be? 29. So that means that x and y are fractions over 29. All right, so now I'm ready to figure out what the numerators are. So here we go. Remember how that works? We take these, and for x, we plug them in right here. So we're going to have negative 11, 13, and 4, 7. And then down here, we'll do the same thing, but we'll plug it in here. So we have 3, negative 2, and negative 11, 13. Is that okay with everyone? Now we're going to evaluate those. So here we go. Negative 77 minus 52. Oh, good grief. That is negative 129 over 29. Check my arithmetic. Is that right? Now, that's hideous. I don't want to have to plug that back in and figure out why. Luckily, I don't need to. 39 minus 22. So that's what, 17 over 29? There's your answer. Now, kids, I have had students in the past that as soon as they learn Cramer's rule, they stop substituting and eliminating, because this takes care of all that hideous arithmetic. It's very fast once you've practiced a couple times. Think you got it? All right, there's one more big thing in our agenda right now, and that is question 3, which says, here is a matrix, find its inverse. It's just some random matrix, and we're going to find its inverse. Now, Payton asked a question a little while ago, because we've been talking about matrix operations, and we did addition and subtraction and multiplication, and she said, do you divide? How do you divide by matrices? Well, you don't. You multiply by the inverse. So you're used to that concept, because if I had 30 divided by 7, Another way of doing that is 30 times 1/7, and 1/7 is called the multiplicative inverse. So you can multiply by the inverse of the number. So here, we're gonna find the inverse, and then if we ever have a need to do a division, we'll have enough, we'll be able to do that. We'll multiply by the inverse. All right, so finding the inverse, I'm sure you did this last year, does anybody remember? It's a two-step process. First thing you do is find the determinant. Step 1, find the determinant. So what is the determinant of that matrix? Negative 34, it sure is. So you put 1 over negative 34. So you start by finding the determinant, and then you're gonna have 1 over that determinant. You're gonna multiply 1 over that determinant times a new matrix you're gonna build. And building the new matrix is pretty easy when it's 2 by 2. It's harder when it's 3 by 3, so we'll do those on our calculator. But building a 2 by 2 is pretty easy. Take these two numbers right here, the main diagonal, those two numbers right there, and simply switch their places. Remember, you're finding an inverse. So you're doing some weird things so stuff will cancel out. So we're going to switch positions. Literally change them. So this goes up here and this goes down here. These other two numbers, you change their sign. Leave them where they are, but change their sign. So, since this is a positive 6, I make it negative. Positive 5, make it negative. Now we're going to multiply through, take all these numbers, times negative 1 over 34. So I'll get negative 4 over 34, positive 5 over 34, 6 over 34, and 1 over 34. And then if anything reduces, I will go ahead and reduce it. So that would be what, negative 2/17. And there is your inverse. If I didn't make any mistakes. In other words, if you multiply that times the original, if you did a multiplication, everything would cancel out. All right, let's check that on our calculator and see how good of a job we did. All right, so we're going to go back into our matrix menu. Where do we go first? We're going to find the inverse of this matrix on our calculator. So where do you think we go first? Go to edit. How big is the matrix we're putting in? Just a baby, 2 by 2. All right, so we're going to put in those numbers. Once I get them in, I'm going to exit right out of there. All right, now, here's what I want you to do. Everybody got the matrix in? So we're going to go back into our matrix menu. And right there, when it comes up, names is highlighted, number 1 is highlighted. That's the matrix you want. Just press enter. So did A come up on your screen? Now, press this button on the calculator because that's your inverse button. So that's going to put the little symbol up here, right? Now press enter. Oh, yuck. Got a bunch of decimals, right? So press math. Enter, enter. Math frac. You just changed it into fractions. And did you get the right answer? Oh, of course we did. So let's do another one by hand, and then we'll check it on our calculator, and then we'll do a 3 by 3 on our calculator. All right. So here we go. We're going to do another one by hand. This is not on the paper. This is a different quiz. All right. So we're going to, first of all, we're going to find it by hand. First of all, we're going to find it by hand. So here we go. Our matrix is 2, 3, 4, 5. We'll just do that one. How simple is that? We're going to find the inverse of this matrix. All right. Who was paying attention? What's step 1? I'm not doing it on my calculator, Evie. Go to my hand first. What do I do? No, I don't do any switching. What do I do first? Find the determinant. Somebody said discriminant. That's embarrassing. It's determinant. So that's going to be 10 minus 12. So we have negative 1/2 this time. Remember, it's 1 over the determinant. 1 over the determinant. Yeah, this one's going to be easier. All right, now what? Now we start doing all the switchy stuff. Now, I'll tell you why. It really doesn't matter, but I like to find the determinant first, because on the off chance the determinant works out to be 0, that could happen. And what would that tell me about my matrix? There isn't an inverse. Because if the determinant were 0, wouldn't I have 1 over 0 here? That's called a non-invertible matrix, and it has implications. There are things that matter about non-invertible matrices. We're interested in finding ones that do have an inverse. So here we're good to go. We got a negative 2. We're fine. So now we take these two and we switch places. And we take these two and we make them negative. You are going to have to be able to find a 2 by 2 inverse, okay? So this is something you have to be able to do without the calculator. We're going to check it on our calculator, but you need to be able to do this. So that first number will be negative 5/2, and then 3/2, and then 2 and negative 1. So that's our inverse by hand. Let's go back to the calculator. We need to go back to edit because we're putting in a new guide. Now, it came out, this is easy. I mean, these are half, these are 0.5, so these are fine. But I want you to get used to that big, long, hideous decimals, changing those into fractions. So all you have to do is press, once you get the decimal form up, just press math. Very first thing highlighted is frac. Just hit enter. Math frac turns decimals into fractions. So you should have exactly what we have up here. Right? So if you didn't, you probably typed something in wrong. It is right. That's what we got. All right, let's do a bigger one now. All right, did everybody get this by hand and on the calculator? All right, so let's do a bigger one now on the calculator. Because finding the inverse of a 3 by 3, again, it's something you used to do, and it's kind of fun. It just takes a long time. So let's find the inverse.
Oh, and then just whatever.
Now, when you're finding the inverse on your calculator, you don't need to worry about the 1 over the determinant and all that. The calculator's going to do the whole thing. So we just go straight to the calculator, over to edit, and now we're going to have a 3 by 3. Just put it in. once you get them all in, remember, this is true of everything we do with matrices. Once you've got your edit done, once you've filled everything in, exit out of there, just a second quit, back to the home screen, and then start in with what you want to do. So we want to find the inverse. So we go to second matrix, hit enter. So it says A now on my screen, I have an A. Hit that button. Alright, I got a bunch of decimals, doesn't look too bad. I'm going to do math frac on it.
Which word was that?
Right underneath the math button. And I get 4/3, negative 5/3, negative 1, 4/3, negative 2/3, negative 1, and negative 1, 1, 1. Is that what you got for your inverse?
Yes.
That is it. That's all there is.
It says exclamation. Oh,
Now, if you had a need to find an inverse of something bigger than that, like a 4x4, you absolutely could on your calculator, same thing. It would be a nightmare by hand. On the calculator, it's easy. What if you're asked this question? What if A is 1, 2, 3, negative 1, 1, 5, and it says find A inverse? What about that? You can't. Why not? And what difference does that make? There's no determinant. The determinant is a part of the inverse. If you can't find a determinant, you're not going to be able to find an inverse. So that would be no answer, not possible. Can't do it. Just like you can't find its determinant, you cannot find its inverse. Okay? Very, very good. All right, let's see what else we've got here. Okay. All right, let's look on page 2. Page 2 of our packet. All right, down at the bottom, there's a Cramer's rule problem. All right? So what I want you to do right now with your partner is on page 2, down at the bottom, on page 2, down at the bottom, there is a Cramer's rule problem. All right, I want you to do it. You are on page 2, down at the bottom. You're doing the Cramer's rule problem. I'm doing something else. You're doing the Cramer's rule problem. We're practicing Cramer's rule. All right, what'd you come up with when you solved that problem with Cramer's rule? So did everybody get 23 sevenths, 3 sevenths? 23 sevenths, 3 sevenths, you said, right? All right, everybody got that? We're all fine. Cramer's rule, we got it. So quiz next time, which will be Monday. We have a Cramer's rule problem on there. Everybody's good?
Yes.
Okay. Now, I want to look at, in the box on there, in the box, it says find the area of this triangle. And I wanted to do this because many of you are going to be taking the exam, and this is probably going to be an exam question. So I remind you of a few things. So, let's go through this step by step. First of all, I drew the triangle. Oh, by the way, the answer's 9. I drew the triangle. So here are the given points. I just threw them up there and connected. Now, one way of finding the area of a triangle is 1/2 side, side, side. Would you agree? And you got other options. 1/2 base times height's not going to work too well here because you don't know the height, but you could also do Hero's formula, if you remember that. Square root S minus A, S minus B, S minus C. I chose what I think is the easiest, which is 1/2 side, side, side. So, I found this vector, AB. So I went from here to here. So that was 2, 6. And then I found vector AC. So that was -2, 3. And then I found the magnitude of those, so that I knew the length of this side. When I do the magnitude, I square, add them together and square root. So the magnitude of that one was root 40, and the magnitude of this one was root 13. Those were the magnitudes. Then the only thing I was missing was this angle. So I remembered that in order to find the angle between two vectors, dot product equals magnitude times cosine. Oh my gosh, maybe I forgot that. So I'm reminding you, dot product equals magnitude times cosine. So I know the dot product here. The dot product is -4 plus 18, so that's 14. I know my magnitudes, so root 40 times root 13. So I just divided and then second cosine to get that angle. So then my area is 1/2 side sine of that angle. Now, I'm getting ready to show you something that is gonna absolutely knock your socks off. It will, I promise. Next time, somebody gives you a couple or 3 points and says, find the area of the triangle. Try this. Build the vectors just like I started. So I'm building AB and AC. Okay? Instead of writing those as separate vectors, let's put them together in a little determinant. Now let's evaluate that determinant. What's the value of that determinant? What's half of 18?
Oh my god.
That is the area of the triangle.
Stop.
That is the area of the triangle.
She did show it to her.
Huh?
She did show it to her.
Did you show us that when we
Yes, she
like,
did.
the chapter?
Did I?
Yeah.
I might have, because I think it's so awesome. I talk about it every chance I get. It's absolutely amazing to me how that works. Now, when you take the 1/2, that makes sense because every time you talk about area of a triangle, whether it's 1/2 sine, 1/2 base times height, Hero's formula, which involves the semi-perimeter, half the perimeter, you always take half when you're finding the area of a triangle. So you're going to evaluate the determinant, take half. If the determinant happens to turn out to be negative, forget the negative, the area is a positive number. So if this were to come out to be negative 18, I would still say the area is 9. Okay? Pretty darn slick. I like it a lot. All right, let's look at the back of that page. Now, the question says, find or use the inverse method by hand. No, we're not going to do that. We don't have time. What we're going to do instead is use the inverse method on our calculator. Okay? We're going to use the inverse method on our calculator. Now, here's how that would work. And I don't even want you to write this down. I just want you to really think about it for a minute. This system of equations, I'll tell you when to start writing. I want you to be watching and thinking. This system of equations could be written like this. Now, before you allow yourselves to be confused, I want to remind you, when I multiply, this is a multiplication here. When I multiply, I take the row times the column, right? First times first plus second times second. So what would that give me? If I did first times first plus second times second, wouldn't it give me x plus 2y equals 8? So this is just the matrix form of that system of equations, right? Now, if you're solving this, you want to know what x and y equal. You want to get rid of this, right? Now this comes back to Peyton's question. I mean, wouldn't it be awesome if I could just divide that out? But we can't divide by a matrix. So what do I do instead to get rid of it? I multiply it by its inverse. So if I multiplied by the inverse of this, wouldn't that cancel that out for me? But if I multiply by the inverse on this side, obviously I have to multiply by the inverse on this side, right? Now, you're tempted to do this. You can't, because this is a 2 by 1 and this is a 2 by 2. That's not going to work. So when you multiply, you got to do your inverse in here. That's where your inverse has to be, in there. So now you have a 2 by 2 by a 2 by 1, and that'll work out for you. So this is going to be gone. Your answer is essentially gonna be what then? How am I gonna get my answer? The inverse times these numbers? So when I do this question on the back of page 2, my answer is going to be the inverse of this times 8/3. Does that make sense to you in terms of what I outlined down here? You need to cancel those coefficients out. So you're going to multiply by the inverse. So the inverse times those numbers is going to be my answer. Okay? We're going to put two matrices in now. We're going to put this matrix in. We'll call it A. We're going to put this matrix in. We'll call it B. Alright? We're not doing the inverse yet. We're just putting in the matrix. So go into your matrix menu, across to edit. Matrix A is 2 by 2. Alright, so everybody's putting this in as matrix A. We're not doing the inverse part. We're just putting these numbers in as matrix A. Got it in? Alright, so we're going to quit. Now we're going to go back into matrix. Go across to edit, but down to B now. You gotta go down to B, because you're gonna put in matrix B, which has what dimensions? How many rows?
2.
How many columns? So it's a 2 by 1. You're gonna put in 8 and 3. And then exit out. Now we're going to tell the calculator to multiply the inverse of A times B. So we'll go back into matrix. A inverse times back into matrix. Click down to B. And the answer is 2, 3. That is called the inverse method. And to solve a system using the inverse method, it takes about 5 seconds on the calculator. You just type in your coefficients, you type in your constants as 2 separate matrices, and then you multiply A inverse times B.
So does X equal to Y equal to?
Yep, yep, that's exactly right. Exactly right. All right, let's try one of those that's a little bit bigger. And the answer to this is probably going to be hideous because I'm making it up as I go.
Oh.
All right, hang on. We got 10 more minutes. We can do it.
What?
Get up,
3 minutes.
I have 3 minutes. Oh, it's 9:07, isn't it? Oh, well, I probably aren't going to get to this. So someone remind me on Monday that this is where I have to start.